Okay, let's look at a couple examples and see how the test statistic rejection region way of doing these hypothesis test conclusions works versus how the p-value way works. And I'm sorry that this got cut off so weird. I will fix that before I upload your version. But the question starts with, suppose that we have a right-tailed test performed with null hypothesis being that mu is equal to 3.2 and the alternate being that mu is greater than 3.2, with the significance level of alpha equals 0.05. The results of the test produce a critical value of z equals 1.9, a z-test statistic of 2.24, and a p-value of 0.013. So we have all of this information from our test. They did give us z-values, so this must have been able to be performed as a z-test. First, it asks us to draw the related normal curve. Then we're going to use the two different approaches to come to a conclusion. And we hope our conclusion matches because they should. So let's see what's going on here. We've got a normal curve. We know that because we've got the z-test going on here. And I'm going to just draw a line here for the center. So whenever it tells us that we get a z value of 1.9, that means that, let's say, is right here. That's the critical value. It's the boundary line. So what that means is that our rejection region is everything to the right of that value. Then it tells us that the test statistic came out as 2.24. So I'm going to write that with a different color. The test statistic, I'm going to call that TS for right here, was 2.24. So what we can see is we can see that the test statistic has fallen into that rejection region, which means that we can use this first approach to come to a conclusion. So if the test statistic falls in the rejection region, it means we have enough evidence to reject the null. Since the test statistic falls in the rejection region, we have enough evidence to reject H sub naught, or the null. And what that means is that there is enough evidence to support. So again, we've rejected the null. We've rejected this idea up here, which means there's enough evidence to support the alternate, that the mean value is greater than 3.2. Let's look at how the p-value approach works. So what we've got, whenever we have that test statistic, when we have that critical value that makes the boundary, for that what is out here has an alpha value of, in this case, 0.05. So when P came out, it says as 0.013, what the p-value is, let me pick, I need yet again a different color. Sorry, I'm trying to keep everything sort of its own color. I'm going to pick this weird orange color. So this area right here is the p-value of 0.013. So the area past that critical value is alpha, but the area past the test statistic is p. Notice what we have here. We have the situation where p is less than alpha. 0.013 is less than 0.05. So you have to be able to compare decimals. You have to know what a decimal is larger or smaller than another. So that is true. P is less than alpha in this case. So based on what we just learned, when the P is low, the null must go. So since P is less than alpha, we reject the null. That's good. That's what we already knew we were going to do with the other method. So this method gives us the same result. And we can write the same conclusion as above. I'm not going to rewrite it because we just did the same exact conclusion just using two different methods. But you can sort of see how they work together, just two different ways to think about it. Okay, so let's look at one more example. On this one, it says, a social media content specialist is looking for ways to use social media platforms to build an audience. It is known that the average number of social media posts per day that helps to build an audience is 3 daily posts. After posting on social media for a few months, the content specialist believes that the average number of posts per day needed to build an audience is not really 3 posts. First, let's write our null and our alternate hypotheses. So we have to build these from scratch. So it says that, it's known that on average, it's supposed to be 3 daily posts. So what we're told is that the mu value is 3. We're told that it's an average of 3 daily posts. But this specialist is claiming that it's not really 3. So that's the alternative, that mu is not 3. So this is a two-tailed test. It says using an alpha of 0.01, the critical values are calculated as z equals negative 2.58 and positive 2.58. The z test statistic is calculated as negative 1.17 and the p-value comes out as 0.242. Draw the associated normal curve with all parts labeled and then decide whether to reject the null or not and write your final conclusion. So let's see, let's draw this normal curve and make it, so I've got lots of space to do things here. So let's see, we've got our critical values of negative 2.58 and 2.58. They'll always, if it's a two-tailed test, they'll always be the same values, plus and minus. So this creates our two rejection regions, both upper and lower. And let's see, we've got a test statistic of negative 1.17. So the test statistic fell right here, and the test statistic is also a z. So it's a z equals negative 1.17. Okay, so now let's see. We have then to decide based on all of this whether we should reject the null or not and write the conclusion. So let's look at it both ways. So the first way we look at it is I see that that test statistic does not fall in the rejection region. So, or hence, there is not enough evidence to reject the null. We fail to reject the null. So we have to basically just stick with it that there has not been enough evidence to say that it's something other than 3. We have to just stick with the 3. Again, we haven't proved, I'm not going to say I've proved that it's definitely 3. I just don't have any evidence at this time to say that it's something else. I might want to go back and collect more data, do this for longer to get a bigger sample. Okay, but that's all we can say right now is that we've failed in our attempt to reject that null. We can also look at it with the p-value approach. So let's see, we've got a p of 0.242 and an alpha value of 0.01. So p is definitely larger than alpha in this case. So we fail to reject the null in this case as well. Okay, so we have failed to show that the mean number of posts is not 3. We failed in this attempt. We failed at trying to show this. So that's the final conclusion, is that I can't show that it's something other than 3.